There's an animal alive today that holds a record nobody expected it to keep forever. The blue whale. 200 tons, 80 feet of pure mass. For decades, scientists didn't just call it the biggest animal alive, they called it the biggest animal possible. Not because evolution ran out of ideas, but because the math simply didn't allow anything heavier. Push past that weight, and biology itself breaks down. The blue whale wasn't just a record holder, it was a hard ceiling. Then somebody dug up a jawbone on a beach in England, and that ceiling cracked. The animal that bone belonged to is called the Ichthyotitan, and it is the only creature in the entire fossil record that has ever genuinely threatened the blue whale's crown. The wild part? It wasn't even close to being a whale. So let's actually settle what biggest means before we go any further, because this gets confusing fast. When people argue about the largest animal ever, they almost always mean mass, pure, raw, biological weight. And the reason that matters is because length is basically a useless measurement without context. Take the Argentinosaurus, a dinosaur, stretched out to around 115 feet, which sounds like it demolishes the blue whale. Except most of that was a pencil-thin neck and a tail that weighed almost nothing. Total body weight? Maybe 80 or 90 tons. Impressive, but a blue whale is more than double that. Or consider the bootlace worm, which can grow past 180 feet. It also weighs roughly the same as a damp towel. Length without density is just a party trick. The blue whale wins because it is dense. There's just an enormous amount of animal packed into it. A 200-ton wall of muscle, fat, and bone. That's what puts it at the top. Now, where does the Ichthyotitan land? Estimates for the largest specimen found in the UK put it somewhere around 85 feet and roughly 120 tons. At first glance, that sounds like a clear blue whale victory. But here's where it gets interesting. That 200-ton figure for blue whales? That's the record, the absolute freak of the species. One individual weighed 209 tons. The average adult blue whale is actually sitting between 100 and 150 tons, which puts it in almost exactly the same range as the Ichthyotitan estimates. These two animals were fighting for the same weight class, and we've barely scratched the surface of what the Ichthyotitan was capable of. Here's the problem with the fossil record. We have measured thousands of blue whales. They're alive, they're enormous, and they're not particularly sneaky. With the Ichthyotitan, the total evidence we have is 2 jawbones. Out of millions of animals that lived across millions of years, we found 2. The mathematical odds that either of those happened to come from the biggest individual in the species? Essentially 0. But there's another bone that changes everything. Before the Ichthyotitan even had an official name, paleontologists found a different jawbone in a place called Ost. It was older, it was bigger, and for years nobody knew what to do with it because it was so absurdly large that claiming it as a real animal felt like professional suicide. So it sat in storage, classified as a mystery, while scientists quietly argued about it behind closed doors. That bone is now called the Ost colossus. Now that we understand what Ichthyotitan looked like, researchers can look back at the Ost bone and recognize the same architecture, same animal, or at least the same type of giant, just scaled up. When you plug the Ost colossus dimensions into the standard size equations, the numbers stop making sense in the best possible way. You're looking at something close to 95 feet long and pushing toward 175 tons. That's still technically under the record blue whale, but the Ost colossus almost certainly wasn't the biggest Ichthyotitan either. It's just the biggest one we found. If you treat 175 tons the way scientists treat 120-ton blue whales, as a large adult, not an outlier, and then you model what the extreme upper end of the species looked like, the projection hits somewhere around 280 tons. That would make the largest Ichthyotitans significantly heavier than anything alive today. Is that confirmed? No. Is it impossible? Also no. The honest answer is we just don't know. 3 bones, 2 Ichthyotitan jaws, and the Ost colossus is the entire dataset. That's not a sample size. That's barely a footnote. Here's what makes this animal even stranger. It was a reptile. Look at a reconstruction of the Ichthyotitan, and your brain is going to say dolphin. The torpedo body, the dorsal fin, the flippers, it checks every box. But it is not a mammal. It's an ichthyosaur, a marine reptile from the Triassic period. The reason it looks like a dolphin isn't coincidence, and it isn't cheating. It's convergent evolution. The process where completely unrelated animals solve the same physical problem and land on the same solution. Dolphins evolved it, sharks evolved it, ichthyosaurs evolved it. If you want to move fast through water, physics basically hands you the blueprint. There's only one shape that works well, and everyone ends up using it. So why was a reptile getting this heavy? Reptiles are usually the lean, fast, agile option. A mosasaur is terrifying, but it's athletic. It's not hauling around 100 tons of mass. The answer is the deep ocean. The Ichthyotitan wasn't a coastline predator. It was fully pelagic, meaning it lived and hunted in open water, far from any shore, crossing vast stretches of empty ocean. And in that environment, being massive is actually the efficient choice. The physics of drag work in favor of larger bodies at consistent speeds.
Massive, dude.
A cruise ship burns far less fuel per mile than a speedboat does. By becoming an 85-foot torpedo, the Ichthyotitan could cross ocean distances without burning through its energy reserves. The exact same trick modern blue whales figured out independently. Size also solved the temperature problem.
Massive, dude.
The deep ocean is cold, and reptiles normally struggle in the cold. But past a certain body mass, you unlock something called gigantothermy. Your body becomes so large that heat can't escape faster than it's produced. You essentially become self-heating. This let the Ichthyotitan hunt at depth, in cold water, in ways that smaller reptiles couldn't. And underwater, gravity stops being the enemy it is on land. A 100-ton land animal collapses under its own weight. Your skeleton can't handle it. But water provides buoyancy. You don't need legs capable of supporting your mass. You just need to stay afloat. That's why the ceiling on land animals sits around 80 or 90 tons, while ocean animals can push past 200. The ocean removes the structural limit that evolution can't get around on dry ground. The last ingredient was food, and the late Triassic ocean had food. Enormous cephalopods, giant fish, other marine reptiles. The biomass floating around in those seas was staggering. And more importantly, nobody else was eating it at Ichthyotitan scale. No whales yet, no megalodons, no mosasaurs. Once this animal crossed a certain size threshold, it had no competition whatsoever. Natural selection basically handed it a blank check and said, keep going. So it did. And then, 201 million years ago, the Triassic ended. Not quietly. The Central Atlantic Magmatic Province, which is the technical term for the Earth splitting open and flooding the atmosphere with volcanic gases for thousands of years. CO2 levels spiked, global temperatures shifted, the oceans acidified. The Ichthyotitan didn't die from the heat or the acid directly. What died was everything it ate. The buffet closed. And when you are a 200-ton animal that requires millions of calories daily just to maintain basic functions, a collapsing food web isn't a setback, it's a death sentence. The largest animals starve first because they have the largest fuel requirements. Ichthyosaurs as a group survived into the Jurassic, but they did it by shrinking. They abandoned the massive deep ocean strategy and pivoted to being smaller, faster, and more flexible. The Titan scale niche they had occupied went completely empty.
And it stayed empty for 200 million years. Plesiosaurs, mosasaurs, they were fearsome. But a mosasaur at its biggest tops out around 15 to 20 tons. That's not even in the conversation. The Titan scale ocean predator slot sat vacant from the end of the Triassic until around 50 million years ago, when land mammals that had returned to the sea evolved into whales, and specifically discovered filter feeding on krill, which is the only food source abundant enough to fuel a 150-ton body in the modern ocean. The Ichthyotitan was a one-time event, a specific combination of warm recovery seas, unstable oxygen cycles, abundant food, and zero competition that let one lineage of reptiles reach a size that evolution has never repeated in anything that isn't a mammal.
Could there have been something even bigger that left no trace? It's not a ridiculous question. Consider, we found 3 bones. 3. Paleontologists estimate that under 0.01% of all animals that ever existed left any fossil at all, and we've recovered a fraction of even that. The entire history of Ichthyotitan is reconstructed from what amounts to debris. And the fact that we did find those bones is actually the suspicious part. If 200-ton animals were 1 in a billion biological accidents, the odds of their fossils washing up on a random beach in England are basically 0. The fact that we found them suggests these animals may have been far more common than 3 bones implies. Which raises the question, what didn't we find? Somewhere under rock, or dissolved by time, or sitting at the bottom of an ocean we'll never excavate, there may have been something that makes the Ichthyotitan look like a warm-up act. An animal that lived during a peak of oxygen abundance and food density and simply grew until physics said stop, and then vanished without a trace. We have no way to know. We're reading 3 torn pages and trying to describe the whole library. What we do know is this. The blue whale did not invent the giant ocean predator. It reinvented it. 200 million years earlier, a reptile figured out the same strategy, reached the same scale, and ruled an ocean that no mammal had ever touched. The blue whale is remarkable, but it wasn't first. It was second.